Hi, here I am going to discuss about the predicates and quantifiers, the semester 2 Mathematics for Computing 1 syllabus by using 3 past paper questions. Question number 1. Suppose we have two predicates px and qx as given. Px is x less than 2, qx is x greater than or equals to 2. Here we can find the truth value of px and qx by substituting the values for the variable x. The substituting values will be natural numbers. That means 1, 2, 3 up to infinity. 0 is not there. Which of the following propositions are true? For any natural number x, either p or q will be true, but not both. For any simple n belongs to capital N, either p or q will be true, not both. So let's see where we have p as true, where we have q as true. So for the xi values, we can find the truth value for pxi and qxi. Xi values are 1, 2, 3, 4 up to infinity. Pxi, when x equals 1, we know that 1 is less than 2. So px will be true. Px true. 1 is not greater than or equals to 2. So qx will be false. See, as I told you before, one of these two will be true, the other one will be false. When x equals 2 and 3 and up to so on, always that value will be greater than or equals to 2. So for all these cases, after x equals 1, q is true and p is false. The same combination will be repeated hereafter. So we know that px is true only when x equals 1. In that case, qx will be false. All the qxi values will be true for all x greater than or equals to 2 values. Qx is true for all x greater than or equals to 2 values. First one, all x, px and qx. This one will be true when we have both as true only. As I told you before, there are no any x value, no any x value that makes both as true. So definitely there are no at least one x value which makes the conjunction between these two as true. That can't happen. So this is wrong. Part B. All x, px or qx. Since for all the x values, we noticed either p true or q true. So definitely Px or Qx is true. Since we have this for all x value in the natural numbers, so this is true for all x values. C. All x Px. This is wrong. Why? As we noticed, Px will be true when x equals 1 only. So not for all x. D. There exists x, Px or Qx as true. That means we have at least one x, which makes this disjunction as true. Yes, we have, because since for all x values we have either P true or Q true. So when you select any x value there, you can identify at least one x out of that, which makes this one as true. So this is correct. E. As in part A, we noticed there are no any x value which makes the conjunction between P and Q makes true. So there are no x values which makes this capital A as true. So again E is incorrect. Since here we have there exist, that means we should have at least one x. Since there are no x, there are no at least one x either. So the final answer is B and D. Second question. Depending on the sets x and y, we have to identify the proposition which is true out of the 5 propositions given. First one, all x there exist at least y, x less than y. This means we should be able to identify at least one y value. Suppose we have y1, which makes the relation x less than y as true for all the x values. We should be able to identify all the ordered pairs like this. So basically here we do not have a y value which is greater than 30 and 40. So we will not be able to identify a y value for the ordered pair with 30 comma and 40 comma. Here we do not have a y value. So this is wrong. Part B. All y there exists x, x less than y. This means for all y there exists at least one x which satisfied this relation. So at least one x is there such that x less than y, but for all y. But here we do not have a x value which is less than 6. So for all this, we can take x equals 10. That is less than all these values. But 10 is not less than 6. So we do not have x value which is less than 6. So this is also wrong. C. There exists x, all y, x less than y. This is same as the proposition that we had in part B, because here also we have there exists at least one x, which makes this relation is true for all the y values. Same thing, we do not have x value mapped with 6 in y. So this is also wrong. Part D. There exists x, there exists y, x less than y. This means we have at least one x and at least one y, which makes this relation as true. Yes, we have. It is enough to identify at least one pair like that. Yes, we have 10, 12. We have at least one y, at least one x, which makes this relation as true, because 10 is less than 12. Part E. All x, all y, x less than y. As I told you before, this is also wrong, since we do not have an ordered pair for the element 6 in y. We do not have x nor x. So the answer is D only. Third question. Here we have to deal with the predicate px and we have to identify an equivalent proposition for this thing. Here we have negation, there exists x, px. The meaning is not of at least one x, which makes px as true. Furthermore, we can rewrite this thing as there is no at least one x, which makes px as true. Again, this is same thing if we have for all x, px is false. Since we do not have at least one x, which makes px as true, that implies for all x, px is false. We can rewrite this thing by using quantifier. Then here we have all x, px is false is negation of px. So this is the equivalent proposition for this. Same as negation, there exists x, px. So the answer is C only. Thank you for watching. Please subscribe to see more videos.